everyone. Thanks for joining the Residential Performance Path Training. I'm Courtney Anderson with Denver's Office of Climate Action, Sustainability, and Resiliency. And this is our third training in the residential series. We developed this with our partners in community planning and development. I know people are still joining the session, but we're going to go ahead and get started with the interpretation instructions. So the session's available in both English and Spanish. And to get to that side of Zoom, please click on the interpretation icon when you see that come up at the bottom of the screen. So I'm going to hand this over to our interpreter, Chessie, today to explain this in Spanish.
Esta sesión está disponible en inglés y español. Haga clic en el icono Interpretación en la parte inferior de la ventana de Zoom y elija inglés o español.
Great.
So,
go
ahead.
I was just saying, Linda, you're up.
So everybody, welcome. Our presentation today will cover the total building performance and the energy rating index compliance paths for residential construction. I'm Linda Morrison. I lead the energy review team for community planning and development. I'm really glad that you're joining us to get more experience with these paths and feel very comfortable applying them. The session today lasts about 90 minutes. After our prepared material, we'll have a Q&A answer session inside those 90 minutes. So please type questions at any time using the Zoom Q&A feature. If you have a question that's not related to the energy code, please direct that over to an email address, which is residentialpermits, all one word, @denvergov.org. We will use the Zoom chat feature during the presentation to answer some basic questions like where to find information, and we'll hold more complex questions until our Q&A session. During that session, the moderator will say the questions out loud so our community planning and development panel can respond. If we're unable to answer your question in our time together today, we will answer it via email. So this presentation will be recorded and posted to the website. If we can go on to the next schedule slide here. We've had previous presentations in this series about a general compliance overview, which is great and foundational. That might be helpful for your deeper understanding, as well as one that was focused on the prescriptive path. So please join us for the future sessions in the series or by getting the recorded version. And please help us get the word out by sharing what you've learned and links with your colleagues and interested people. Continuing education credit for people who attend the full session is available. If you called in by phone and want credit, please email Tom Gleason, tom.gleason @denvergov.org so he gets your full information. Let's go to the timeline, which helps to recap Denver's plans and goals for greenhouse gas emissions. The 2022 Denver Energy Code became effective on May 1st, and it's a step in a series of steps that take us to our goal of zero greenhouse gas emissions. Energy efficiency is foundational, but it alone does not achieve the goal. It takes a combination of efficiency, electrification, and a greener grid. So this means we all have a part to play in making these changes, and we also have time to accomplish them incrementally. Our energy code includes input from a wide variety of community members and stakeholders, so a great big thank you to all those who contributed. You will find the 2022 Denver Energy Code at denvergov.org/building code. A package of proposed changes to the code is posted there. It's anticipated to get City Council approval later in June, now scheduled for the 20th. The updates are primarily housekeeping in nature, and this presentation has a preview. Please do check back to the website for the latest code and updates to resources. The Denver-specific ComCheck and ResCheck are anticipated to be available in fall of 2023. Another place where you'll find resources is at the Net Zero Energy Hub at denvergov.org/energy code. This has a recording of this presentation, as well as other resources for specific provisions, compliance options, and other training materials. More resources are being added, so please be sure to check back. So tips for referencing the code. You're going to hear us use a single reference to a code section in the 2022 Denver Energy Code. This is because the 2022 Denver Building Fire and Code adopts the base code as reference. It's a good practice to check Denver's code first to see if there are additions, deletions, or modifications to a section, and then also reference the base code. Also, Chapter 11 of the Denver Residential Code is replaced in its entirety by the residential provisions of the 2022 Denver Energy Code. Now let's go to today's presentation. Tom Gleason is our moderator. He's with the Office of Climate Action, Sustainability, and Resiliency. Rachel Ranazan is my colleague on the Energy Review team, and Robbie Schwartz with Build Tank is our presenter.
Great. Thanks so much, Linda. I appreciate it. Again, I'm Robbie Schwartz, and I'll be presenting today's presentation on the 2022 Denver Energy Code Residential Performance Compliance Pathways. I'm actually going to turn off my video so you can concentrate on the slides, and then I'll turn it back on when we get to Q&A at the end of our session here. Today we'll be talking about a compliance overview specifically with regards to the performance compliance options. We'll be talking about energy modeling and trade-offs using those performance options, which are the total building performance and the energy rating index compliance options. And then we'll talk about some considerations for existing buildings with regards to performance options as well. So before we begin really diving in, we need to take a moment to review how Denver defines the residential buildings. And residential buildings and these definitions are in Chapter 2 of the IACC. And it states that residential buildings are detached 1 and 2 family dwellings and multiple single family dwellings such as townhouses, and group R3 and R4 buildings 3 stories or less in height. So the residential provisions of the 2022 Denver Energy Code apply specifically to residential buildings as defined here, which is why we need to understand this definition in more depth. You may notice in the lower left-hand corner of the slide that the definition is actually located in the commercial section of the Denver Energy Code. And it's located there because there are residential buildings like apartment buildings that are over 3 stories tall and must comply with the commercial versions or provisions of the code, not the residential provisions. Another definition that we really need to understand well is new to the Denver Energy Code, which is this definition of all electric properties. In the city's effort to promote the electrification of homes, this definition is used in several places in the Denver Energy Code, where compliance for all electric properties differ from non-all electric properties. So an all electric property is a property that contains no permanently installed equipment or appliances that utilize gas or gas equipment for combustion within the building or even on the site itself. The exception for this is for emergency power systems and standby power systems, such as gas-powered generators. So you need to note that there is no exception for a gas fireplace, indoors or outdoors, or a gas barbecue there. Now, this is important to understand because some of you might be involved with the Marshall Fire rebuild, and electrification is defined a little bit differently up there. So be sure you understand this definition of all electric properties. Now, the residential projects that you are going to be submitting to the city can comply with 3 different compliance options. But we're going to be talking specifically about the total building performance option and the energy rating index option for compliance today. We did cover the prescriptive compliance option last week, and that recording will be posted on the City of Denver's website. In addition, there's a short overview compliance pathway training that covers all the compliance options that you could take a look at. And lastly, I wanted to remind you that this presentation will also be uploaded to the City of Denver's website for future reference if you need to go there and take a look at it. So you're going to be submitting your construction documents and other compliance documents to the city of Denver. This will include what's called the Energy Code Checklist. And it's important to take a look at that Energy Code Checklist, as it is a guide, or actually a checklist, to guide you through all of the submittal requirements that are needed to obtain your building permit. Some of those submittal requirements are these compliance reports that could be your res check report or cost compliance report or energy rating index compliance report, as well as your HVAC design documents, your manual J, S, and D. In addition, your construction documents need to be complete and house all of the required elements, and also be stamped by a registered design professional. Now, some of those additional compliance requirements that have to be on those construction documents would be, for example, a depiction of the building thermal envelope, air sealing details, and those types of things that we'll be talking about in more depth in the upcoming inspection and contractor trainings that start off on June 22nd and also on June 29th. Pretty much at the same time that this presentation happens. So around 1 o'clock, those presentations. So you want to make sure that you sign up for those presentations and listen to those. Even if you aren't a contractor or an inspector, it'll give you a better idea of the full kind of scope of inspections and requirements that are needed on your construction documents. Now, the construction documents, well, I'm one slide ahead of myself here. Before we get to that, I wanted to note that the Denver Energy Code amendments now better define what an approved third party is. An approved third party is allowed to inspect your project. And if you choose to use a third party, you're now eligible for a discount of $150 on your permit fee. Third parties are most often used when demonstrating compliance using the performance option of the code, because compliance reports have to be turned in not only for the building permit, but also to issue the certificate of occupancy. These compliance reports use the specifications and the building performance testing data that are actually achieved in the field in a second energy model to create what we call the confirmed compliance report that you need to turn in for that certificate of occupancy. We'll be discussing this all in a lot more detail here during this presentation. But those wishing to be an approved third party need to contact the city of Denver, and those projects wishing to do the energy code inspections through a third party will need to submit a document called the Homeowner Energy Rater Verification Form with your permit application. And a picture basically of that document, the Home Energy Rater Verification Form, is what's shown on this slide. Now, those construction documents, again, are documents that the plan review team utilizes to help guide the inspection process. So a lot of the information that's on those construction documents are included in the permit scope of work text box for the inspectors that go out into the field. So the documents need to include the compliance pathway, for example, so that can be noted on the scope of work text box notation, so that the field inspection team knows exactly how to inspect that home and what to inspect it for. Some of the additional information that needs to be on those construction documents, for example, of if you're using the prescriptive pathway for compliance, would be additional energy efficiency packages, and or regardless of the compliance pathway, if you're putting renewable energy systems on the house, and or if that house or property is an all-electric property or not. Okay, so because the building performance options utilize an energy modeling process here, we're going to talk a little bit more depth about what energy modeling and the result of energy modeling, which is these trade-offs, what they are and how they actually work. So there are a number of energy modeling softwares available that you can use to demonstrate compliance with the total building performance pathway and also the energy rating index or ERI compliance pathway. What you need to know is that ResCheck is not one of them, as it can only be used to model compliance for the total UA alternative compliance option. You also want to note that you're likely to be confused a little bit when you enter into the ResCheck software because they have this kind of quasi performance compliance option. But I want to be really crystal clear here that that performance compliance option within ResCheck does not model for the total building performance approach or the energy rating index compliance approach. So you want to be clear to stay away from that if you're choosing these compliance options here. So there's another software out there called Energy Gauge that can do this modeling for total building performance and energy rating index. But that software really is only used in Florida and some of the southeastern United states there. And it's really unlikely that you're going to see it in Colorado. The two softwares that are used most commonly in Colorado are the REM-Rate software and the Ecotrope software. And those are the softwares that we're going to be showing some example reports and whatnot of during this presentation here. So both the building performance approach and the energy rating index compliance options utilize this whole building energy modeling to simulate the building's energy use and compare the proposed design to what we call a reference home or a reference design. This encourages holistic design process and also allows for more compliance flexibility through what we call an energy trade-off. Now, the energy modeler who will be performing this third party will probably be an approved third party, and depending on the performance compliance option that you choose and the software that's used, it will most likely be an energy rater. So these trade-offs refer to ultimately putting something more in one assembly so that you can put something less in another assembly while keeping a balanced scale or a balanced energy budget that is deemed to be compliant with the code. So when you're using the performance approaches, you're allowed to trade off more things than you normally would be allowed to if you're using the prescriptive approaches. The area weighted U value prescriptive approach does allow you to trade off U factors and R values, but the performance approaches not only allow you to trade off U factors and R values, but they also allow you to trade off air tightness, duct leakage, systems and appliance performance, depending on the appliance approach that you're trying to achieve. So if we look at the scale below here, and we think of the blue ball representing maybe attic ceiling insulation at R38, which is significantly less than the required R60 there, that is allowed if you use a performance trade-off approach or a software modeling trade-off approach. What it means, though, is that on the other side of the scale, the three silver balls might represent better windows, reduced air leakage, better duct location, all inside the conditioned space, all things that exceed the minimum requirements. Therefore, the balance of the energy equation is maintained, and you're able to do something less in one assembly by doing something more in another assembly. And that's the way you ultimately get flexibility in figuring out how you want to design and specify the energy performance of that house or the energy characteristics in all of the different assemblies there. So when we're doing these energy models, we utilize a software, and the software describes the thermal building envelope and its delta T location to ambient air or dirt. Therefore, the energy modeler has to start off by doing a takeoff of the building and input the square footage of each of the building assemblies into the software. In essence, they're rebuilding the house within the software, demonstrating where each assembly is placed with respect to its delta T location in order to describe ultimately where the heat loss or heat gain is happening within that building. there. And remember, when we're talking about heat loss and heat gain, we're talking about the direction of heat flow. Heat flow is always happening from higher concentrations to lower concentrations. You can think of it as from more to less or from hot to cold. In this way, the energy model describes and calculates the heat loss and heat gain through the building thermal envelope of the entirety of that building that's being energy modeled there. Now, within the energy model, after you've built the house in there, the energy model kind of takes over, and it takes that geometry and it builds two houses that are geometric twins of each other. One of those houses is called the reference home, and the other house is called the rated home. Now, the rated home could also be called the reference, not the reference design, the proposed design, or the builder's house. And what happens within that software, because these two houses are geometric twins of each other, the rated home is compared to the reference home, because the reference home is defined as a house that has a standard set of house specifications that generate a specific, a consistent, and a quantifiable amount of energy performance that is equivalent to the code. So the reference home is in essence is overlaid with the specifications, the R value and U value specifications that are equivalent to code compliance. The rated home is overlaid with the specifications that the builder and the design team are thinking that they want to use, and they compare the rated home to the reference home to see if it's equal to in performance or is better than performing better than the reference home. And there are a variety of different metrics that can be used to determine if it's equal to or better than. And that's ultimately what we're going to be getting at in each of the performance compliance options here. Now, there are a variety of different reference homes out there, and these softwares can demonstrate compliance with a lot of these different performance options or different performance pathways through the code. But remember that if you're using the area weighted U value energy modeling approach, you can only use the ResCheck software. That's the prescriptive compliance option that uses a software modeling approach. And if you're using the total building performance approach or the R406 energy rating index approach, you can use either the REM-rate software or the Ecotrope software or some of the other softwares that are out there to demonstrate compliance there. Now, ultimately, this process creates a whole building or a holistic energy model that helps us better understand the building science that's wrapped into the energy code, which helps us and allows us perform greater trade-offs and gain more flexibility in how the home is designed and specified and ultimately built in relationship to the code specifications and compliance with the code. So when we talk about flexibility that's built into the code, we're talking about using these performance approaches and the energy models to be able to determine that flexibility in how we design and specify the building thermal envelope assemblies. Now we're going to jump into the first of these options here. You have the option to use the total building compliance option here. Now, this section is in R405, and it establishes a criteria for compliance using total building performance analysis. The analysis only includes heating, cooling, mechanical ventilation, service water heating use, and building assemblies or components that directly affect the energy performance of the building's thermal envelope from a heating, cooling, ventilation, and service hot water perspective there. Now, this compliance option does not include mechanical or solar trade-offs. However, it offers more flexibility than the UA alternative because you can trade off more than just R values and U values that are allowed in that prescriptive energy modeling approach. As you can see in the pie chart on the right of this slide, heating, cooling, and water heating are the largest energy demands of a home, and this is why the code concentrates on these areas and their impact on the building thermal envelope. So the code is always trying to protect the performance of the building thermal envelope there. Within the energy model itself, two houses are developed that are geometric twins of each other. We have the reference home that I talked about before, and the reference home specifications for this compliance path are actually defined within the body of the energy code in table R405.4.2 parentheses 1 in the IECC. So if you're interested in looking for how the reference home is built, you can go there and you can actually see how the reference home is defined. Now, the proposed design or the builder's house uses the specifications set by the designer or the builder or that whole design team there. Now, remember that there are some envelope backstops that are designed to protect the performance of the building thermal envelope from overly aggressive trade-offs. And I'll show you those here in a second here. But backstop specifications, you need to consider those backstops when the proposed design specifications are set to ensure that you're going to have a house that will comply and be ultimately better than or equal to the reference home that is going to be compared to. For the total building performance compliance approach in the 2022 Denver Energy Code, it requires that all electric homes be 5% better than the standard reference design, and that all other buildings or non-all electric buildings, in other words, be 18% better than the standard reference design. The metric used for compliance to ultimately determine if the proposed design is better than or equal to that 5% or 18% is annual energy cost. So the result of the energy model is what we call a cost compliance report that will show you if the house is better than 5% or 18%, depending on how your project is defined there. And I'll show you those reports here in just a bit. The standard reference home design is what we're ultimately looking for here. And it's what you must be 5% or 18% better than, depending on the building and if that building is an all electric property or not. Remember that the reference home design is printed in a table within the body of the 2021 IECC, so you can go take a look at it if you'd like to, and that the reference home is this standard set of house specifications that generate a specific, a consistent, and a quantifiable amount of energy use that is deemed to be compliant with the code. And this is what we're comparing our proposed design or builder's house to. So the builder or proposed design specifications must be chosen to demonstrate compliance that is now 5% better than or 18% better than, depending on the project type that you are proposing to build to, and ultimately better than the reference home by those percentages. So what does this mean for your project? The proposed design must meet first the requirements in table R405.2 that I'll show you here in a second, comply with these backstops, meaning that you can't trade off below the building thermal envelope requirements described in the 2009 IECC. Now, this backstop ultimately and in reality is irrelevant to the Denver Energy Code, because the Denver Energy Code is using the 5% and 18% cost compliance requirements, depending on if you're building an electric home or a non-electric home. But you want to be sure that you are specifying something that is better than the 2009 IECC R values and U values in those tables there, just to ensure that you're not going to have any issues when it comes to looking at this compliance and the energy modeling that's happening there. So lastly, you have to comply with the cost compliance requirements that help to incentivize all electric properties. And you can see that the non-electric property has to be 18% better than the reference home versus the all electric property that only has to be 5% better than the reference home. Therefore, they've set this up to incentivize people to seriously look at building all electric properties within the city of Denver there. So regardless of the compliance approach that is used for the project, there are these additional requirements from sections R401 through R404 that must be met. The 2021 IECC removed the language that describes requirements as prescriptive or mandatory, and they're now just listed out as requirements, and they're listed out per compliance option there. In essence, you can think of them as mandatory requirements that primarily address installation-specific issues that deal with efficiency in the code. Now, for the total building performance compliance option, they're listed in this requirements table. This is the
Hello, can everybody hear me now?
This is the R405.2 table there. We'll be speaking to these requirements in more depth again in the contractor training, which I recommend again that you take a listen to or join us on June 22nd and June 29th there. Now, you can see, if you look at this table in depth, you can see why they got rid of the language, the mandatory and prescriptive language there. If you look in the left-hand column there, you'll see attic eave baffles. Now, attic eave baffles used to be described in what was called the prescriptive section. So some smart aleck really thought that if they were doing a performance approach compliance for their house, and it had a ventilated attic, that they weren't required to install attic eave baffles because it didn't say mandatory on it. Now it's just really clear by using this table that all of these things are required if you're doing an assembly that would need attic eave baffles, like that ventilated attic, for example, there. The other thing I want to just touch on again is the backstop. It's used in the total building performance compliance pathway, and it states again that the building thermal envelope shall be greater than or equal to the levels of efficiencies that are in the 2009 International Energy Conservation Code. Again, the Energy Code uses the backstops to protect the performance of the building thermal envelope from excess trade-offs. And as I said before, it's unlikely that this will become an issue since your cost compliance requirements are 5% better than or 18% better than the reference home that's using the R values and U values or U factor tables from the 2021 IECC. But regardless, it's really smart to just keep this in mind in case there's some unforeseen trade-off that complies on paper and may not comply, in reality in the field during field inspections and whatnot there. I also want to point out that these additional efficiency packages in section R408 are only required for projects following the prescriptive compliance pathway and are not required when using either the total building performance or the energy rating index compliance pathways. The reason for this is that the additional efficiency that has been built in to the code has been built in directly into the performance requirements for both the total building performance and energy rating indexes. Remember, in the total building performance, this 5% better than and 18% better than the reference home is a demonstration of how they've built in this already into the compliance pathway there. Note that the original printing of the Denver Energy Code in section R401.2.5 in the requirements table for both the performance approach and the energy rating index approach, these requirement tables R405.2 and R406.2 point to a requirement for additional energy efficiency, but that was a mistake that was written into the code and it's been removed, and there's now an errata that's been issued to show clearly that that is not a requirement. Now, the errata is supposed to be published soon on the City of Denver's website, and it's recommended that you download it and reference it when determining compliance for your project so you understand everything that's actually required. An errata is a document ultimately that publishes things that were printed incorrectly in the first versions of the printed version of the codes, and it fixes that in the errata And again, that's why you want to go to that errata document on the Denver Energy Code website in order to make sure that you're looking at the corrected versions of the Denver Energy Code. Okay, so like the prescriptive compliance option, a cost compliance report for the proposed design must be turned in for permitting. This report must be marked as proposed because the energy modeling includes air leakage and duct leakage, which has not yet been determined for the actual built home. The Energy Code details out specifically what needs to be included on these reports, including demonstrating that the proposed design meets the requirements of sections R402, which we just discussed. Those are the requirements that are from sections R401 through R404, such as the air leakage requirements, duct leakage requirements, and those types of things. Other things that have to be on the compliance report are shown here in the yellow box. Most importantly, a certificate indicating that the proposed and confirmed design has an annual energy cost that is less than or equal to that required by the Denver Energy Code, which is the 5% better than for the all-electric buildings and the 18% better than the reference home for non-all-electric buildings. Also, you want to note, again, we want to note that this has been set up to incentivize all electric buildings here. Okay. So here's an example of a cost compliance report from the REMrate software. Note that this example home passes the 2021 IECC by 7%. Remember that this meets the requirements for all electric properties within the Denver Energy Code, but would not meet the energy savings requirements for mixed fuel or non-all-electric homes. Also note that neither the REMrate or the Ecotrope software has been modified to include the Denver Energy Code amendments. So this is one fundamental reason why the 5% and the 18% levels of performance have been set within the Denver Energy Code. It allows the use of softwares without having to customize the software to a code adoption and its amendments. In addition, the Denver Energy Code amendments to the cost compliance requirements provide better equivalency between compliance options and helps the city of Denver meet the zero carbon and zero energy goals that they have. Here's another example of a cost compliance report, and this time it's from the Ecotrope software. This house is showing compliance of 5% better than the 2021 IECC, which meets the requirements for an all-electric home, but again, not the requirements for a non-all-electric home in the Denver Energy Code. Remember that regardless of the software that generates the report, that the report must note if it's a proposed design for permitting purposes or a confirmed report that must be submitted to obtain the certificate of occupancy here. The proposed and the confirmed notations will be noted in the header information at the top of the software report. And on this particular example, it would be in this location here where it says inspection status, results are projected here. An additional compliance report is required when using the total building performance compliance option. This actually requires two separate reports that can be printed out from these softwares. One that outlines the inputs and the specifications used to create the reference home, and another that outlines all the inputs and specifications used to build the rated home or the proposed design. Now, these reports shown here are from the Ecotrope software and also need to be labeled as proposed or confirmed. And you can see up in the upper right-hand corner of the document on the right here that it's showing that the results are from the projected or proposed design. I guess I should point that out, that projected also is the same meaning as proposed. In addition, the R401.3 certificate can be printed out from these softwares. This report must be posted in the house as part of the compliance reports that are needed to obtain the certificate of occupancy. Notice that on this slide, the report on the right was not generated by a software. When using the prescriptive R value or U factor compliance option, this is a option that does not use a software, and therefore you don't have the option of printing out this R401.3 certificate from a software. Therefore, the certificate itself has to be hand generated. This particular one uses Microsoft Word, but you're likely to see a lot of different options out there to generate this certificate. In fact, the City of Denver has a template for the R401.3 certificate that you can use to generate the certificate and turn it in to the City of Denver and post it in the house. Note that the section R401.3 states specifically what has to be on the certificate. So if you do generate it yourself, you want to make sure that you have all the requirements that need to be listed on that certificate listed on the certificate. Now, when you're utilizing a software to do the building performance approach for compliance, it's likely that that software also can be used to do the energy rating index compliance as well, and or just generate a energy rating index score. I want to be clear here that if you're choosing to use the R405 building performance compliance option, you should not turn in anything that has an energy rating index score on it. It just confuses everybody and creates this confusion of not knowing which compliance option you're actually trying to use there. So again, do not turn in anything that has an energy rating index on it if you are choosing to use the R405 total building performance compliance alternative or compliance pathway here. Sorry about that. You might hear a phone ringing in the back. Upon completion of the building, a confirmed compliance report based on the confirmed condition of the building has to be submitted to the code official before a certificate of occupancy is issued. The confirmed compliance report is your final site-specific cost compliance report that includes any information obtained during the inspection process of the home, such as the actual blower door test or duct leakage testing results. It can also include any insulation specifications that may have changed between the proposed design submission and the final confirmed report for certification of occupancy. Generally speaking, if you install more than you specified on the proposed compliance documents, you'll be okay. But remember that if your specification changes a lot from what you turned in at submission to the final there, or include specifications that are less than the proposed design, you may run into a big problem at final there. So you want to follow your design as much as possible. Although we do know that things sometimes change during the construction process. You'll want to bring that up as soon as possible there. Now, this documentation of all inputs entered into the software used to produce the results for the reference design and the rated home are required to be turned in as well. So you want to make sure that you've generated all those reports at final in order to get your certificate of occupancy. So just to quickly review, you have a software out there, then you're comparing the rated home to the reference home, and you're ensuring that the rated home is better than or equal to either 5% better than the reference home or 18% better than the reference home, depending on if you're building an all-electric property or a non-all-electric property. You also have to turn in a compliance document for permitting a proposed design or projected report, and you have to turn in a confirmed report for your certificate of occupancy there. Now we're going to move on to looking at the energy rating index compliance option here. Okay, so a home energy rating is a calculated measure of the home's energy efficiency compared to a baseline or a reference home. And I'm guessing that that sounds a little bit familiar to you. The most well-known energy rating index available is the ResNet-HERS Energy Rating Index. The ResNet stands for Residential Energy Services Network, and HERS stands for Home Energy Rating System. The HERS Energy Rating Index scoring system is a proprietary index established in its current form in 2006 by ResNet. ResNet is the governing body of the home energy rating system, and it was created by the Mortgage National Industry Standards body originally in 1995. The original 1995 energy rating index scoring system used an ascending index scale rather than a descending index scale that's actually used today. And I'll show you that the scale that's used today here in just a minute here. First, I want to explain a little bit more about the energy rating index. The energy rating index uses an energy model to perform a holistic energy assessment of the home. The energy model includes lighting, appliances, mechanical efficiencies, as well as R values and U values, and much, much more to do what is called an asset rating. An asset rating evaluates the energy efficiency assets of the home and does not include the behavioral aspects of energy efficiency of our houses there. In addition, an asset rating evaluates energy efficiency components of the building and describes in the energy model how they will perform as installed. Therefore, an asset rating does not care if a feature has been installed in compliance with the code or not, and therefore there are other requirements in the code that specifically address installation there. And also the inspection process will address installation of energy components there. You can think of the energy rating index score as a miles per gallon rating for a house. It doesn't matter who manufactured the house or the size of that house, in the same way that it doesn't matter who manufactured a car or the size of the car when you're evaluating it using a miles per gallon rating. You simply get an idea of how that car or that house performs. An energy rating index score of 100 benchmarks the reference home for the energy rating index system, and the energy performance of that reference home is benchmarked as a house that performs to the 2006 International Energy Conservation Code. Since the year 2006, the energy rating index score has adopted a descending score system so that the score of 0 is equivalent to a net zero energy home. It's important to understand what net zero means because it's energy source agnostic, meaning that over the course of a year, gas and electricity energy use is netted out with renewables to create a net zero energy home. This is why to obtain a zero energy rating index score, you will always have to install some type of renewables on the home. In fact, if you maximize the envelope and mechanical efficiencies in a house, you can only get to an energy rating index score of about 35 at its lowest there. Renewables such as PV panels is what ultimately takes you the rest of the way to zero and zero energy there. Lastly, the Department of Energy has determined that 130 is about the level of efficiency of the average existing home that's out there in the marketplace right now. So in 2022, the average ResNet-HERS energy rating index score in Colorado is about 57. And I've seen houses that are much better than 57, in fact, much better than 0. Houses that are negative 20, for example, are houses that are producing way more power than they are using. And so they're very efficient, but they probably also have oversized renewable systems on that house. I've also seen houses that perform really poorly. I think the worst house that I've seen is a house that scored about 300 points on the energy rating index scale there. So significantly worse than the average existing home in the marketplace there. Now, the energy rating index was first added to the IECC compliance option in 2015 at the International Energy Conservation Code development hearings. They used the name energy rating index, or ERI, because the term HERS, or home energy rating system, is a proprietary term, and proprietary terms can't be used within the body of the code. However, in the 2015 IECC, the energy rating index score was developed using the ResNet HERS standard, even though it was not specifically referenced in the code, because the reality was that there was no other alternative to use. Between the 2015 IECC and the 2018 IECC, the organization ANSI, ResNet, and the International Code Council created the ANSI Standard 301 that outlines how to develop an energy rating index score. The energy rating index became non-proprietary because of this ANSI Standard 301, and the ANSI Standard 301-2014 was adopted for use in the 2018 IECC. The ANSI standard is now used to create both the IECC and the ResNet HERS energy rating index score. Although the IECC uses the ANSI 301 standard to create the energy rating index score in the energy code, during the code development hearings, they actually amended the ANSI standard itself, and they amended the ANSI standard's ventilation requirements in section R403.3 within the body of the IECC. So this changed the ANSI 301 standard, resulting in an IECC energy rating index score and a ResNet HERS energy rating index score for the same house that is significantly different from each other. It also means that we have to be really clear when we're talking about energy rating index scores and use a modifier before ERI so that we know if we're talking about the IECC ERI or the HERS ERI, or energy rating index score. Therefore, like many other jurisdictions around the country, the Denver Energy Code has adopted the energy rating index based only on the ANSI ResNet ICC Standard 301 with no ventilation amendment. And they did this in order to align the energy rating index score with the HERS energy rating index score. The goal of this adoption is to simplify the process and gain alignment and eliminate any confusion with the use of the ERI for demonstrating code compliance. So to be really crystal clear, the ResNet HERS energy rating index score is the compliance score used by the Denver Energy Code. So I just want to repeat that one more time. The ResNet HERS energy rating index score is the compliance score used by the Denver Energy Code. So how is the energy rating index score developed in the software? Remember that within the software, we have two houses that are geometric twins of each other, and they've been created within the software after we've done a takeoff and we built that house in the software. You have the proposed design, which is compared to the reference home. The reference home is overlaid with the specifications required by the ANSI Standard 301, which is equivalent to the performance created by the 2006 International Energy Conservation Code. The proposed design uses the specifications that the builder or the designer has specified for that house. And the objective is to get an analysis to benchmark the proposed design on the energy rating index scoring system in relationship to the ANSI 301 reference home, that 2006 IECC house. In other words, we want to know, does the proposed design perform better or worse than the reference design, and what is its actual score? So what this means for your project is that the specifications for your proposed design need to be able to perform significantly better than the 2006 IECC. And in fact, they need to perform well enough to achieve an energy rating index of 55 or less for an all-electric home and or 50 or less for all other properties or non-all-electric homes. In addition, your project will have to comply with the requirements listed in Table R406.2, which are the requirements that are specified in sections R401 through R404 that all compliance options have to comply with. So remember, I said that if you maximize the envelope and mechanical efficiencies in the house, you can only get to an ERI score of about 35. The remainder of the pathway to zero is achieved by adding renewables, such as PV panels. Because of this fact, the Denver Energy Code set the required energy rating index scores, as I said before, at 55 or less for all electric homes and 50 or less for non-all electric homes at those levels. And also remember that this also means that you have to achieve those energy rating index scores without including renewables in the energy model. So before renewables are added to the energy model, you have to achieve your 55 or your 50 or better, depending on the type of project that you're building there. This really creates a natural backstop to protect the efficiency of the building thermal envelope and offers a more defined path to meet the city's zero energy goals, as well as it offers room to lower the energy rating index scores requirements in future code cycles in order to ultimately meet those zero carbon and zero energy goals in the future. Again, what this means for you is that you will have to turn in a proposed energy rating compliance certificate at permitting and a confirmed energy rating certificate for the actual built home before the certificate of occupancy can be released. The energy rating score must meet the ERI requirements that are laid out specifically in the Denver Energy Code. Those are the requirements of 55 or less for an all-electric home and 50 or less for non-all-electric homes. You can see how these scores have been developed to incentivize all-electric homes within the city of Denver. Here's the R406.2 table, which lists all the requirements, again, that are applicable in sections R401 through R405 for the energy rating compliance pathway. Remember that the 2021 IECC removed the language that described prescriptive and mandatory, or described the requirements as prescriptive and mandatory. They are now just requirements. You can think of them as mandatory requirements that primarily address installation of specific efficiency measures that are embodied within the language of the code. We'll be, again, speaking to these requirements in more depth during the contractors training. And again, I encourage you to take a listen to those trainings that happen on June 22nd and June 29th, or listen to the recordings that will be posted on the Denver website. Also, I want to remind you again that the additional efficiency packages in sections R408 are only required for projects following the prescriptive compliance pathway and are not required when using either the total building performance or energy rating index pathways. As with the total building performance compliance path, you'll have to submit a proposed design compliance report to obtain the building permit when using the energy rating index compliance option here. The reason for this is that the energy model has not, is basically using assumptions such as how air leakage, how leaky the house is, because this information isn't available at the time you're permitting the house. Because the house isn't complete yet, and those tests haven't actually been done yet. The Energy Code actually calls out specifically what needs to be reported for permitting and to obtain the certificate of occupancy for both the performance compliance pathway and the energy rating index pathway. And again, I recommend that you become familiar with those requirements. The Denver Energy Code spells out that an approved third party will create the energy code model that's used for the compliance using the energy rating index compliance pathway here. However, compliance inspections for table R406, those requirements in sections R401 through R404 may be done by either the City of Denver or through an approved third party. So to be clear, in order to create the confirmed energy rating index score and other compliance documents that you'll need, the third party will have to inspect the home during the construction process. Therefore, you're going to have to make a choice, and it might be more streamlined or advantageous to only work with the approved third party for your energy code inspections. However, you can opt to have the City of Denver do those inspections as well. But remember, the energy rater will have to come out and confirm what's been done in that house and will be out there doing some level of inspection anyway. In order to do that, you will need to submit, in order to use the third party, really, you'll need to submit a home energy rater verification form in addition to the other required permitting documents at permit submittal. A benefit of this, again, is that you get a $150 discount on your permit fee. In addition, you will have to submit a complete energy rater inspection form before the final inspection to document compliance. Now, there's more information about this, and it can be found on the Residential Energy Code policy, which is housed on the City of Denver's website. I want to be sure that you know that section R105.4, approved third-party inspection agencies, has been amended in the Denver Energy Code. We'll be speaking to these amendments in more depth in the contractor inspector trainings on June 22nd and 29th. If you can't join us for those trainings, again, I recommend that you download those trainings and look at those, and or go directly to the Denver Energy Code and look at section R105.4, approved third-party inspection agencies, and understand how approved third parties are specifically defined now within the Denver Energy Code. This is an example of the proposed design compliance certificate for the energy compliance pathway, the energy rating index compliance pathway. Remember that I'm only showing you a report from one of the many softwares that can be used to develop a house and the energy rating index certificate. The certificate itself must note if it's a proposed design or confirmed design, and must clearly list the HERS energy rating index score the home has achieved. Remember that this does not make sense it doesn't make sense to turn anything in that is over 55 for all electric homes or a 50 for non-all electric homes, as that certificate and that compliance will be rejected by the city. Most of the softwares give you the ability on the home energy rating certificate to list codes and programs that the home might comply with in addition to this energy rating index score. That's this section here that's been X'd out here. It's been X'd out because I recommend that this ability be turned off in the software so that there is no confusion, and because the software has not been updated with any specific Denver Energy Code specifications and can't list the Denver Energy Code's IECC as a compliant pathway there. So just because it may show compliance with the 2021 International Energy Conservation Code, it doesn't mean that the house is compliant with the 2022 Denver Energy Code itself there. So if you remove this box, you'll avoid any confusion, and everybody will just be looking at the HERS energy rating index score to determine if it's compliant or not. Lastly, all the reports must be signed and include all the information required within the Energy Code, and those requirements are listed in section R406.7.2 that outlines all those things that need to be included on the compliance reports. Here's another example of a compliance report that has the confirmed notation on it. And this is a home energy rating certificate, and you will see that it looks much like the proposed certificate, but that it is clearly labeled as confirmed here. Again, you want to take out or turn off the code and program compliance box on these reports. This report is turned in after the home is completed and before the certificate of occupancy is released, because it certifies that the actual specifications and testing results that were found in the field have been incorporated within the energy model and within this report. The Ecotrope and the REMrate softwares are the primary softwares that are used in the Denver metro area, and reports from either of the softwares are allowed here. On the left side of this slide, you'll see an example of an acceptable REMrate home energy rating certificate. On the right side of this slide, you'll see a report that is for the 2021 IECC energy rating, and it is the IECC energy rating certificate. This certificate is not a compliance certificate that can be turned in for the city of Denver there. So you want to make sure that you're picking the right certificate and you're using the HERS home energy rating score and the HERS home energy rating certificates within the software to turn in for compliance. And that those certificates are marked clearly if they are proposed designs or projected designs or confirmed design reports to get your building permit or your certificate of occupancy. So again, just like the total building performance approach compliance option, you also have to and are required to turn in the reference home and the rated home summary input reports that detail out all the inputs that went into the energy model for your specific project. This slide is an example of the reports which continue on for many, many pages, listing all the inputs for every assembly and describes the geometry and energy specifications for each assembly for the reference home and the rated or proposed design there. Okay, so I think we have looked pretty well and in great detail at the energy rating index compliance option and the total building performance compliance options. And now I want to end out our presentation by looking at some considerations for existing buildings here. The Denver Energy Code addresses additions, alterations, repairs, as well as change of occupancies in existing buildings in order to maintain and improve the energy efficiency of the altered existing building. It's likely that you will have to clearly define your existing building project in order to determine what you're actually doing with that project from a code perspective. So listed here are the definitions from the Energy Code itself for repairs, alterations, additions, and change of occupancies. And again, what we're talking about is taking some time, looking at these definitions and comparing it to your project so you know if you're just doing an alteration or if you're doing an addition that includes an alteration and or maybe a repair. So these things can meld into each other there a bit. So the Denver Energy Code, the Denver Energy Code addresses, let me just go to this slide here. The Denver Energy Code addresses additions, alterations, and repairs, as well as change of occupancy in existing buildings in order to maintain and improve, again, the efficiency of the altered existing building. Again, you need to define your building here, but we want to note that there is no performance compliance options for projects that are classified as repairs or alterations. They must follow the prescriptive compliance requirements that are listed out in Chapter 5 of the Denver Energy Code. As you're trying to determine what your project is actually going to need to comply with, in the existing home chapter, you might want to ask yourself some questions about that project. For example, does the project scope fall into more than one work category? Is it an addition, alteration, repair, or change of occupancy? If it does fall within more than one work category, you must follow the requirements for each of the applicable section there. You might also ask, what is the increase in the conditioned floor area as a percentage of the total existing above grade conditioned floor area? Because additions that don't exceed 20% increase or 300 square feet, whichever are less, are not required to provide an air barrier detail or heating and cooling equipment sizing calculations and some other things within the body of the existing energy code. You can see in the existing home chapter what it would need to comply with. Lastly, you want to make sure and determine if your house is a historic building, because historic buildings are exempt from most of the 2022 Denver Energy Code provisions. But you would have to permit that house specifically as a historic building and get that historic building designation from the city of Denver as well. Now, compliance with most specifications in the Denver Energy Code apply only to new construction. So ultimately, compliance is simplified for existing buildings here. Now, one small exception to that is with regards to electric vehicles. So let's say, for example, you're doing an addition, and that addition includes a new garage or carport, or even new on-site parking spaces. If any of those things are pertinent to your existing home project, you will be asked to comply with the electric vehicle charging requirements. Otherwise, many of the other requirements that are required in the Denver Energy Code for new buildings are not required for existing homes. But you want to make sure that you're clear before you start your project what's required and what's not required. There are two types of additions defined in the Denver Energy Code for existing homes, and you'll need to determine which type applies to your project. Changes in space conditioning, or when you're taking an unconditioned or low energy space and you're changing it to a conditioned space, is an example of the first type. This would be, for example, taking a finished or existing attic and or a finished or existing basement and turning it into a conditioned space. Then we have all other additions. These are additions that are comprised of all new or additional conditioned space here. Note that regardless of the performance compliance option that you choose, the requirements are the same for both types of additions. There are two building performance options that can be used when you're building an addition. Remember that these options are in addition to the options we discussed in the prescriptive compliance presentation. So you'll want to review all the compliance options for additions when deciding how you're going to proceed with your project here. The first total building performance option requires that the annual energy cost of the proposed design, that would include the addition plus the existing building, be 110% better than the annual energy cost of the standard reference design for the addition plus the existing building. Now, this option includes having to comply with all the requirements in the total building performance requirements table, that R405.2 table. This option would require a proposed and a confirmed energy model on that house. Now, the second total building performance option requires that the annual energy cost or energy use of the addition and the existing building and any alteration that are part of the project be less than or equal to the annual energy cost of the existing building by itself. This would require an energy model of the existing building prior to any work performed in or on that building, and also one after the addition has been constructed on that existing building. You also might want to do what we call a proposed energy model to better ensure that the home with the addition will be better than or equal to the existing building before the addition was added to that building. This compliance option also requires that the addition and any alterations that are part of the project comply with all sections of R405, which would include the air leakage and testing options for that compliance pathway there. When using the Energy Rating Index compliance option for projects undertaking an addition, the Energy Rating Index of the addition and the existing building and any alteration that are part of the project must be less than or equal to the energy rating index of the existing building. So like the total building performance compliance option 2, there are, like that total building performance option, which we discussed a minute ago, that was option 2. You have to comply in basically the same way, but you're using an energy rating index instead of a cost compliance report. This would ultimately require that an energy model of the existing building be done prior to any work performed on it and after the addition was constructed as well. Again, you might also want to do a proposed model to better ensure that the home with the addition is better than or equal to the existing building energy rating index score. This compliance approach also requires that additions and any alterations that are part of the project comply with section R406 in its entirety, which would include energy testing and air leakage testing, for example. So when we're talking about energy performance compliance here, you'll see kind of this common language that the addition and the existing building must be less than or equal to the existing building. In order to accomplish this, the performance compliance options include the need to meet the energy leakage requirements in sections R402.4.1.2, meaning that you will have to do a blower door test on your existing building project if you choose to comply using either the building performance compliance option or the energy rating index compliance option. I mentioned this before, but I want to mention it again here, that alterations and repairs must meet the prescriptive requirements outlined in the Denver Energy Code sections R403 and R503 and R504 respectively. Those are the existing sections in the existing homes chapter. You'll want to review the previous trainings that covered the prescriptive compliance pathway in more depth, and those are loaded on the Denver website. Remember the importance of determining if your project includes an alteration, repair, addition, or change of occupancy before you permit your project. And if you need help figuring this out, you can reach out to the City of Denver directly. Projects with a change of occupancy or use to the residential building must meet the applicable requirements of Chapter 5, as it will result in either an addition, an alteration, or a repair. If the change is from a lower energy demand category as defined in the IBC occupancies, it must meet all the requirements for new construction unless the change does not result in increases in energy demand. The problem is determining if there's an increase in energy demand. So the exception to this is when the total UA alternative is used to demonstrate compliance. The total UA of the proposed design may be up to 110% of the total maximum UA calculated. If you decide to use the energy rating index compliance pathway, the project will have to meet the requirements of the energy scoring outlined in the R406 pathways, unless the change of occupancy is part of an addition, in which case the energy rating index must be less than or equal to the energy rating index of the existing building, as we discussed earlier. Okay, so we're winding down here, and I want to make sure that you know that the Denver Energy Code and the Denver Energy Code websites have a lot of resources for existing buildings. The resources such as rebates for homeowners and guides for designers. You need to look at the website that are listed on this page in order to get more information there. This slide also has website information for contractors on how to work with the Office of Climate Action, Sustainability, and Resiliency with regards to rebate programs for existing homes. A lot of these rebates are only for existing homes, not for new homes. Just so you know, the Climate Action and Sustainability and Resiliency Office is looking for stories and feedback from contractors on how heat pump installations are going, and if you are doing an all-electric project, how that is going. So if you would like to share your story, please reach out to the CASR team at the email that's provided on the slide. So to summarize here, the total building performance and the energy rating index compliance options utilize whole building energy modeling that allows more flexibility in determining your specifications because they allow greater ability to do trade-offs here. And all electric properties have easier pathways to compliance under both options there, so that you can see clearly that the city of Denver is trying to incentivize the construction of all electric properties. In addition to performance requirements, projects must meet all requirements outlined in the requirements tables, section R405.2 for the total building performance approach, and section R406.2 for the energy rating index compliance approach. Remember that additional efficiency packages, that section R408 of the Denver Energy Code, are not required if you choose to use the performance compliance pathways. The Denver Energy Code allows relaxed performance requirements for additions to existing homes and change of occupancies as well. And we went over that a little bit, but you can get more information on that on the City of Denver's website. So thanks so much for joining us today for this presentation. Remember that it's going to be posted on the city's website and that we're available to take some questions right now. And those questions will be moderated by Tom.
Awesome. Thank you, Robbie. Good presentation. And I'm just going to jump right in because we have 9 minutes and quite a few questions. So I'm going to start with this one, and Rachel, hopefully you can help me out. If HVAC design is updated after initial permit application, say to add an ERV, does the building performance compliance report need to be updated and resubmitted?
So short answer, yes. For both total building performance and ERI, you need to submit both a compliance report at the beginning showing your proposed design, but also submit one at the end of your project showing that represents the actual as-built conditions. And this can capture any changes that happen in the field, just to make sure that the final design actually also meets the requirements of the code. And we will talk a lot more about the requirements for that final compliance report in the contractor and inspector trainings.
Great. I have another question on here. Does an installed biofuel or ethanol fireplace meet the all-electric building requirements or definition?
So the definition for all electric properties does specify that any installed appliances or equipment that utilize combustion are not allowed. So in this case, even though you're not using natural gas, this is still a combustion appliance. So in this case, it would not meet the requirements for an all electric property. But I did want to touch on that the definition for all electric property doesn't include any non-permanently installed things that use fuel. So say if you have a propane gas or a propane barbecue in your backyard, or if you have one of those propane heaters on your patio, that doesn't count towards this this definition. We're really only looking at permanently installed equipment that uses fuel gas for combustion.
Thank you, Rachel. Good clarification. Let's see. We have another one on here. Okay, someone asked 2021 IECC has a 5% cap on OPP contribution to the ERI. So is it even possible to get an ERI of 0 or less?
So remember that the Denver Energy Code is not using the IECC Energy Rating Index score. It's using the HERS Energy Rating Index score. So you want to go into the Denver Energy Code amendment, and you'll see that that requirement in IECC has actually been removed.
I wanted to add here too that there is a difference between your ERI for energy code compliance, which in the Denver Energy Code that doesn't allow any on-site power production to be used towards that score. So that's looking at just the house as it is without any renewables. But that house, if it does have installed renewables, will still have an ERI that can be lower. That would be it's just ResNet HERS ERI. So there's a difference between maybe the overall ERI for a house when you can look at the contribution of renewables versus the score that you're using just for compliance with the energy code. So a house may have 2 scores when you're looking at renewables or not, and renewables just aren't allowed to be used for compliance with the ERI pathway.
And we have a similar question that I think either or both of y'all can help answer. Can you confirm Denver deleted all of R401.2.5, including number 3, that would require 5% less than the ERA target specified in R406.5?
Yes, this is correct. So Denver amended the IECC to remove the IECC's version of this additional efficiency packages, which did have provisions both for total building performance or ERI. And instead, we took that out and tried to simplify it by including that kind of additional efficiency or a little bit of reach within the requirements of each section. So R401.2.5 is not in the Denver Energy Code, and the kind of mistaken reference to it in the table of requirements for total building performance and ERI has been removed, as Robbie mentioned, in the errata. So if you are following either of these performance or either of these compliance pathways, the kind of additional efficiency is built into the requirements within the Denver Energy Code.
And another related question, Jeremy wants to know, if we are pursuing the ERA pathway, you mentioned we need to submit the HERS as model document, but it's not clear what other documents are needed for that ERI pathway. How do we show compliance with R406.5?
So maybe Robbie, you can go to the slide about compliance documentation. So for your permit submittal, you are submitting the compliance report, the modeling report that shows that you're meeting the requirements. And there's also a section within the code that specifies everything that's needed to be included within that compliance report. And additionally, there's the table of requirements that you need to meet, which is what your third-party inspector would be looking at and verifying that you're meeting all those additional provisions, those mandatory provisions. And I want to point you also to our energy code checklists. These can be not just resources for you to fill out at the end, but they can be really helpful resources to print early in your process and help guide you through all of the requirements to show that you're meeting every single provision. So it gives a lot more context on exactly what the submitter will be want you to include in the permit documentation. And we will cover in the contractor inspector trainings in more detail what we will require before the certificate of occupancy is released.
Yeah, just to quickly add to that, in the body of the software, Jeremy's question is basically saying there is a checkbox in the body of the software that says that these items have been looked at in the code. For the cost compliance report, you'll be submitting that, and it will say that on that report that these things have been met. for the energy rating index pathway, it really is relying on field inspection and the code checklist to ensure that all of these provisions of the code have been met, because you don't have the ability to use that checkbox in the software for the ERI pathway for the city of Denver.
And thank you, Rachel, for sharing that link. I've put that in the chat for everybody to access. We have 1 minute and one question remaining. So the last question is, someone has seen advertisements for leasing HVAC equipment. Does the Denver Energy Code allow this option for existing residential properties?
The energy code doesn't really allow or disallow this or specify kind of how equipment is paid for, but whether it's purchased or leased, it just needs to meet all of the requirements of the energy code. That would be the code standpoint for that.
All right, and with that, we are at 2:30. So everyone, thank you for joining us today. So we will make sure to send out this recording as well as a copy of the slides to all attendees today. So hang tight and just keep an eye on your inboxes. We imagine that'll be sent out in probably the next week or two, but you will get an email notification. So if you haven't seen that, again, just bear with us and we'll get that out to you. We'll also send, if there are any questions we didn't get to today, we'll follow up offline, and we will be back for the residential contractor and inspector considerations training on June 22nd. So taking a little break, and we'll be back with that series starting June 22nd and the following week on June 29th. So hope to see you again. Thanks for joining us, and y'all have a good one.